Okay, welcome everyone to our webinar, How to Achieve Zero Carbon with Safe, Healthy and Sustainable Homes. Today we are delighted to be joined by Tom Woolley, who is an architect at Rachel Bevan Architects, a visiting professor at the Centre for Alternative Technology and chair of the UK Clean Air Steering Committee. Tom has extensive practice experience in Scotland and London, specialising in the renovation of old buildings and working with community groups. He is a former professor of architecture at Queen's University Belfast, an editor of the award-winning Green Building Digest, and has written many publications. He is also a former chairman of the Northern Ireland Building Regulations Advisory Committee and currently a member of the Ministerial Advisory Committee. His main input to practice is by undertaking research and consultancy work in ecological materials and educational advisory work. Today, Tom will discuss using bio-based low-embodied energy materials, particularly hemp crete, to produce zero-carbon healthy buildings and achieve good indoor air quality. As always, there will be the chance for questions at the end of the presentation, so please submit these in the Q&A option at the bottom of your screen at any point during the presentation, and I will then ask these on your behalf later on. This presentation is also being recorded and will be uploaded to the IES YouTube channel. Thank you very much for logging in. It's great to see you all here today, and I'll now hand over to Tom. Thank you, Tom.
Thank you very much. I think that's a nice introduction. It saves me saying too much about myself. Hopefully you can all see my slide. It's okay. I'm starting off with a picture on the left of hempcrete being used in renovation, and because I'm going to be talking a bit about hemp, I've got up the logos of the British Hemp Alliance and Hemp Cooperative Ireland that I work quite closely with. So I've been working on low impact building for 30 years now. You hear a lot more about it these days as people talk about zero carbon and net zero. And here are some of my books, which, so I put them up here instead of putting them on the shelf behind me to promote them. And when you get the recording, you can always go back and have a look at these if you're interested in any of them. So the aim of what we're all should be doing at the moment is to save the planet, though you sometimes wonder how many people are really that bothered and are just hoping that the issue will go away. I think it's quite amusing that this book, 7 Years to Save the Planet, was written in 2008 and we're still talking about 7 years to save the planet. And so a lot needs to be done, and some of what I'm talking about will touch on it. Big business, housing organizations, government, everyone's talking now about reducing CO2 emissions, decarbonization, net zero. Unfortunately, being a bit of an old cynic, I'm afraid, I think an awful lot of it is just carrying on as before with a bit more greenwash. And I'm going to talk about ways we can perhaps avoid that problem. And that is essentially by adopting a holistic approach. So embodied energy is the most important thing. That means that we have to check how much energy we're using to save energy. You know, lots of people talk about let's reduce carbon emissions, but they often don't talk about the embodied energy that's spent. Zero carbon should also mean zero pollution. That means we have to reduce our polluting impact on the planet. Then we have to protect the health of building occupants. That's incredibly important. And we have to, and sorry about the typo on here, but actually protest is just as good as protect against fire hazards. And also, how do we save energy effectively without having the problem of the performance gap? So I've been doing an analysis of recent reports just written in the last 4 or 5 years about zero carbon, net zero. I think I've worked my way through 50 reports now about this issue. And one of the things I find very depressing about this is that they're all essentially aspirational. So they tell us over and over and over again, we have to decarbonize, we have to move to net zero, we have to achieve zero carbon, but actually very few of them actually say how that can be done. And one way you can check this is by looking at the subject of insulation. If we want to save carbon, we should insulate our buildings better. but most of these documents barely touch on the topic of insulation. Some of them don't mention it at all. The UK Green Building Council report on zero carbon, for instance, which I don't think is on this particular slide, doesn't mention insulation at all. And many of these documents mention insulation, but only in passing, like insulation is a good thing, but they don't say what kind of insulation or how it should be applied. So it's a worry that all these documents are being produced without people really saying what they're going to do about it. Fortunately, there's the start of some better proposals coming up, and this is a particularly good document which I've come across recently by ESAC. It's a European policy report, and it actually does go into more detail about what needs to be done to achieve decarbonisation. So they get a gold star from me for doing that. They could have gone a lot further, of course, but there's a quotation here, which is about the bio-based insulation materials have much lower levels of embodied emissions. So that is really great. None of the other documents, and particularly documents being produced by organisations in the UK, actually refer to this sort of thing at all. And the document really goes into a great deal of detail about the importance of embodied energy reduction. So I would strongly recommend reading this document if you can find it on the internet. An example of a UK document is from the Construction Leadership Council on greening our existing homes. In fact, it says absolutely nothing, in my view, about greening homes. Insulation is only mentioned 8 times, and in fact 4 of those mentions are about a somewhat questionable retrofit scheme. They do advocate what's called deep retrofit, and there's a thing called Energiesprong, but this is a luxury solution using high embodied energy materials. It's far too expensive and only relevant to a handful of buildings. So there aren't any green solutions, in my view, in this document, and that's fairly typical of the approach which is being adopted here. One of the problems we've got is that most conventional approaches to decarbonisation and insulating buildings advocate the use of plastic, foam, petrochemical based insulation materials. So these materials have the embodied energy which is too high, they're flammable, they're toxic, and they create a serious amount of plastic pollution and waste. Polystyrene is one of the biggest contributors to waste in the oceans, and yet we're still continuing to use it widely on buildings. For instance, the use of polystyrene beads in cavity wall insulation, which I would not advocate at all as a good solution to making buildings more energy efficient, creates serious problems, and microplastics and beads are a particular problem in the oceans, and this really shouldn't be allowed at all, actually, but it's one of the main things which is advocated by government policy. A recent study that I was involved in to some extent in Northern Ireland by the Northern Ireland Housing Executive found that they looked at nearly 1,000 houses that had received cavity wall insulation, and they found that 63% of these houses were defective. So it isn't even a particularly effective way of insulating buildings. And one of the problems we've got in the UK now is a massive problem with mold and damp in buildings as a result of retrofit disasters. These are the result of using non-breathable plastic materials in cavities and on the outside of and inside of walls of buildings. This has become known as the Great Retrofit Disaster, but there's a lot of people still have their heads in the sand about this issue, and not a lot is being done about tackling the problem, because people's lives have been turned into misery as a result of botched insulation schemes. The latest UK government scheme for green homes has been a complete washout, really, and very heavily attacked by by MPs in Parliament for its inadequacies, and the government doesn't seem to learn from these mistakes. Perhaps the best known disaster scheme, but only one of many, is at Fishwick in Preston, which has been very well publicised, where people have had their houses renovated with external wall insulation, only to leave them with serious problems of damp and problems inside their houses. I'm happy to come back to this if you have any questions about it. And essentially the problem here is as a result of the widespread use of petrochemical-based materials. Here you can see a factory. This is BASF in Ludwigshafen. They're one of the biggest producers of petrochemical insulation materials. And these are materials which people assume is what we need to use, but in fact they cause all sorts of problems. Not only do they cause problems of dampness in buildings, but the pollution caused by the manufacturing of these materials is a serious problem. In fact, the pollution problems are so bad that most of the production of the materials used to create these insulations, like isocyanates, has stopped in Europe and has moved to China. And as a result of that, we then have got Cfc emissions coming from these production processes in China, which has been widely publicized in journals like Nature. CFCs were banned by the Montreal Protocol in 1992, but they're still being used as blowing agents in insulation manufacture. The other big problem with these petrochemical materials is that of fires, and the numbers of fires in buildings are increasing. The government's just published its health and safety bill in Parliament, but this is largely focusing on the problem of buildings over 18 meters high, whereas in fact the majority of fires are in buildings underneath that. And it's increasing because of the use of flammable materials in housing. The Grenfell disaster has obviously made many people more aware of these issues, but I still think there's a lot of confusion and misunderstanding about the problems. Grenfell United have been particularly active going after some of the big insulation manufacturers that produce petrochemical insulation materials, and the Grenfell inquiry has exposed terrible problems with the bad state of certification and approval of these kinds of materials, which have allowed dangerous, polluting, flammable materials to be put into buildings, and they continue to be used. Another major problem that we've got is of increased air tightness. It's assumed that in order to make buildings more energy efficient, we have to make them more airtight. That means wrapping them in plastic, which in my view is not the way to go. And there's a particularly interesting project run in Glasgow called the HEMAC project, Health Effects of Modern Airtight Construction, which has led to a number of documents and reports about the problems of this. It just is wrapping everything in plastics is not the way to go. We need to make buildings more breathable and better ventilated, not just sealing them up so that they are supposedly more energy efficient. This has meant that there is a greater awareness now of indoor air quality. Much of the concern about air quality has focused on traffic pollution and external air quality, which does remain a problem. But in fact, 50%, as you can see from this pie chart, is actually about indoor air quality. The effect on people's health from indoor air quality is now being generally accepted to be more serious than that of external air quality. And lots of people have produced reports about this. The Royal College of Pediatrics and Child Health report, British Lung Foundation has been publishing stuff, and the IAQM has recently issued a consultation draft on indoor air quality guidance. So this is a really important issue, but it's very underdeveloped in the UK in particular. As architects, we can test for indoor air quality now. It's something we try to do. we use a relatively affordable way of sampling air from a company called Waverton Analytics. And one of the things that I've discovered when we do this is that the emissions from volatile organic compounds and from formaldehyde tends to be over safe limits in almost every building that we test, including brand new housing. This house that you can see on the slide here not only had high levels of these chemicals, which were a result of the building materials in the building, not the tenants. The tenants had only just moved into the house, and it also had serious problems of mold growth as well. It was a brand new house, quite a nice house as well, but it came already equipped with these toxic chemicals and health problematic materials. So this is something that we need to make people more aware of. So what do you do about that? Well, we try now as architects to build with natural, non-toxic, breathable materials, and to try and reduce the use of petrochemical products as much as possible. But one of the big problems we've got with this is that the eco materials like wood fiber, you can see the use of wood fiber insulation and also cork on this slide. These are coming from the rest of Europe. They're not manufactured in the UK. Cork, obviously not, because we don't have cork trees in the UK, but wood fiber we could easily produce in the UK. We dump hundreds of thousands of tons of wood waste into landfill every year, whereas it could actually be made into wood fiber insulation. But obviously importing it from Europe increases the costs and leads to other problems as well. So this is something that has to change. I know that the UK government is aware of the importance of bio-based materials, but they're not doing anything about supporting industry to develop these products. The material which we use most of all is Hemp Crete, and we produced a guide to Hemp Crete back in 2008, which was published by the BRE Press, and Hemp Crete has been widely used throughout the UK. This is a way of casting solid walls of a building by mixing hemp with lime, usually in conjunction with a timber frame. You can see that on the bottom left. And this is a method for both new building and also for renovation. So on the right, you can see a wall which is being has got hempcrete on it, which is only 50 mil, 2 inches thick. But normally when you're building new, you're building walls about 300, 350 mil thick. And there's a very good guide to hempcrete construction produced by Stenix and Sparrow, published by Green Books. Hemp houses have been around for 30 years now. I'm quite often told by people, particularly Green New Deal campaigners, that they want to use shovel-ready technology. They tell me that we can't wait for you to produce these innovative natural insulation materials. Well, that's nonsense, because we've been using these materials for 30 years and they're well tried and tested and ready to go. So it's a kind of false argument. Here, these houses were built by a housing association in Haverhill, and the hempcrete houses perform better than the two adjoining houses were built out of brick and mineral wool insulation. It's possible to install hempcrete in many ways. You can cast it, you can spray it, you can turn it into blocks. So blocks are not the most efficient way to use the material. And so it's particularly valuable and is used a great deal in the renovation of historic buildings, as you can see here. Here it's being used to renovate listed, well, I'm not sure if it's listed, but certainly in conservation area in Bristol. And the conservation officers seem to be very supportive of the use of hempcrete, where it's been used to replace the old lath and plaster. And there's also an old cottage here in Ireland that's been renovated using hempcrete. So we've applied this material in many ways very successfully. I try to run training workshops around the country. The Carbon Co-op in Manchester is a particularly great organisation, and here are pictures from a couple of workshops that we've run. One in a very cold farm in a couple of years ago, and then last year we did this workshop in Manchester in a housing cooperative, where we were able to do with all these volunteers a whole hempcrete wall. So we teach people about the theory, but we also let them get their hands on the material so they can learn how to use it themselves. Here's some other examples. A small building that was built in at Caermabon in North Wales using hempcrete, again with volunteers who had no previous experience of using hempcrete. And then a project in Austria at the S House, where we've been spreading the idea of hempcrete to many other countries. One of the projects I'm most proud of that we've done is the Rediscovery Centre in Ballymun in Dublin. This is an environmental education and recycling centre. It's also the Irish Centre for the Circular Economy. And here we were able to convert an old boiler house. So we reused much of the steel structure of the building, and then the walls were all cast out of hempcrete. So the building is very, very energy efficient and demonstrates all sorts of other innovative technologies as well. We built a hempcrete cottage in our own garden, which we've been able to monitor over a long period now. And so we put our own money into this project so that we could be sure that we were happy with the technology. And this is recently being monitored by University of Ulster to look at the humidity controlling benefits of using hempcrete, which are a particularly strong feature of this material, as well as the building being very, very energy efficient. This is a house which is currently on site in southwest Scotland, where the hempcrete is sprayed onto the timber frame. This is the hempcrete spraying was all done in 3 weeks, quite a quick, efficient process. It just takes a few more weeks to dry out before the rest of the building work can be completed. One of the great things about hempcrete is it's incredibly fireproof. So to prove this, this is an example of a house that sadly had a very serious fire in North Devon. You can see a little bit of damage to the hempcrete, but that was caused by the fire brigade, who wanted to make sure that the timber frame inside the hempcrete walls was not smouldering. And this house has been fully renovated and got glowing reports from the engineer who did the insurance assessment. So we know that hempcrete is very, very good at resisting fire, unlike many of the other lightweight petrochemical materials which are currently being used in buildings. Hempcrete can be prefabricated. This is a project in Cambridgeshire where the panels were fabricated off-site, and this has also got an innovative cladding material made from a hemp fibre and resin composite into corrugated sheets, so that there are a lot of potential from these bio-based materials. We've done other projects around the world. This is a soup kitchen in Kailicha Township in Cape Town, which is built with hempcrete called Yizek Kaya. And you can see some wonderful films on YouTube of the kids helping to build this building. And we did a project in Chile in a particularly earthquake-prone area. So we'll be able to see how the hempcrete stands up to the earthquake problem. In this case, I had to teach local builders who'd never done hempcrete before how to do hempcrete, and they got it within about half a day, to be quite honest, and I was able to stand back and relax. Even though I couldn't speak any Spanish and they couldn't speak any English, they got it really quickly. It's a very, very simple and easy method to build with. There's lots of other buildings around Europe, multi-story housing built out of hempcrete. It has fantastic potential in that respect. And we use materials which are manufactured in the UK. So we get our lime binder from Kilwater Lime in Northern Ireland and from Lime Green in Shropshire. But there are French products, but we prefer to use the ones that are manufactured here. And the hemp comes from a company in Yorkshire called Harrison Spinks. Harrison Spinks make mattresses from natural wool and hemp, but they have a lot of hemp material left over, which we can use for building. So it's a very nice company to deal with. And again, it means that we've got the materials that are grown and produced locally. We have some certification for this. We have LABSS certification for hempcrete in Scotland, and hopefully before long we'll have LABC certification in English. And there are data sheets and so on. There are some people are very skeptical about using materials if they don't have this kind of certification, and we need to do more work on this. So I hope that's gives you an overview. I've kind of rattled things through fairly quickly. If you look on this slide, there's a link to the Usable Buildings Trust have put on it, posted on it, a talk that I did to the SPAB STBA conference last year. And so if you want something that's a bit longer and a bit more detailed, then you can click on that. So you can download that PDF. So thank you very much for listening, and do get in touch with me. Got my email address here if you want to find out more about this and ask me some questions. But I'm happy to deal with any questions that Ethany's going to come up with from the chat.
Thank you, Tom. That was a really interesting presentation. Really amazing to hear about the new kind of opportunities there are for builds and reducing carbon and improving indoor air quality. So yeah, please everyone put your questions in the Q&A function, and I'll ask these out on your behalf. To kick things off, how does hempcrete compare price-wise to traditional building materials? Do you think the government would need to put an incentive on using materials like this?
Well, that's an interesting question, because at the moment the price of building materials is going up very, very fast, particularly timber, sadly, which is another ecological material. But the cost of the hemp and the lime is actually quite cheap. So the cost of hempcrete construction is largely about how you build with it. Do you use spraying or do you cast it? How good are the builders at building the timber frame and casting and setting up the shuttering and so on? So it's a complex question, because it isn't just about the actual cost of the raw materials. The raw materials are cheap, though, there's no doubt about that, and so we can be really quite price competitive now. Though try telling that to a quantity surveyor who isn't very sympathetic. If he's never heard of hempcrete before, you can be certain that the price will get doubled, but it is actually very affordable. And I think that could be the case with many other bio-based materials. A lot of the products which are imported from Europe, like sheep wool and wood fiber, are far too expensive because they're manufactured in Europe. If we were able to manufacture them here, they'd be equally competitive.
Thank you, Tom. And how can you ensure that the production of the lime that is mixed in with the hemp has zero emissions?
Yeah, producing a lime binder is not zero carbon. It has some embodied energy associated with it. Though I have to say that Lime Green are managing to produce a binder now which actually is very low emissions. I've actually done quite a bit of work on making hempcrete with a clay binder rather than with lime. So that actually brings down the embodied energy quite considerably. What the hempcrete people will argue is that you can offset against the lime energy expended by claiming that the growing the hemp has has actually absorbed CO2 from the growing process. So there's a little bit of an argument that goes round and round there, and it's not totally zero embodied energy because of the lime binder. On the other hand, the lime has huge benefits because of its ability to carbonate and so on. So it's a complicated issue.
Great, thank you. And in terms of embodied carbon, how does the material compare to concrete? Is it 80 to 90% the embodied carbon of concrete?
I would say Hemp Crete is about 20% of the embodied energy of concrete. And cement is still responsible for about 17% of all of CO2 emissions on the planet. So it's a very serious problem. And so Hemp Crete is massively advantageous if you're wanting to reduce carbon.
And does hemp face many hurdles in terms of production in the UK and Ireland? Is it subject to licensing due to the Illegal Substances Act?
No, growing hemp is not a problem. It's fairly easy to get a license now. And in fact, there's a surplus of hemp these days because a lot of countries in Europe have been growing hemp and are trying to offload cheap hemp here. There's still only 2 main hemp processors both in Yorkshire. The problem that you hear in the media about growing hemp is to do with CBD and growing seeds and flowers and so on, and that is still a bit of a mess, and the government really isn't sorting it out. But the hemp that we use doesn't contain any THC or anything like that, so it's absolutely not a problem. The other thing is that the hemp fiber, which you strip off the plant, we're only using for building, we're using the shiv, which is the straw. The fiber is a very valuable product and is widely used now in the aircraft and automotive industries. Again, it's underdeveloped in the UK. Most of that production is happening in Germany and France.
Interesting, thank you. And with all the understandable recent focus on fire safety, has this damaged the image of using bio-based materials, particularly timber? Given the backlog in signing off materials, are these novel materials able to get regulatory approval?
Yeah, well, the timber thing is it's infuriating, because the problem with fires and flammability in buildings is the petrochemical insulation materials which go on fire. It's got nothing to do with the timber. I've even followed quite closely the example of a project where there have been serious concerns about the timber balconies. And actually, after the fire, the timber material in the balconies was still intact. It hadn't actually burned, even though all the press reports said that the fire was due to the timber balconies. So there's a lot of nonsense talked about that. Hemp Crete is probably the most fire-safe material you can use. We can get an hour and a half fire protection. So there is a real danger that there are people out there who want to damage the reputation of bio-based materials. There's no doubt about that. And they will use the fire thing as an excuse, and that is a worry. But all we can do is show people that timber frame with Hemp Crete is about the most safe fire thing you can use.
And are there challenges? Oh, sorry, were you going to come in?
No, that's fine.
Perfect. Are there any challenges using Hemp Crete in buildings which require gas protection measures?
I'm not sure. Is this somebody's asking about radon? Probably. I mean, you can use Hemp Crete in floors, but if you do that, you need a breathable floor, so it's not really suitable if you've got to put in a radon barrier. But it isn't a problem in terms of walling and use in roofing materials, so I don't think it's a problem.
Great, thank you. And an attendee here has just said that they finished renovating an old house, and one of the main difficulties they came up against was that the builder they used wanted to use the materials they were used to. So how do we get these new materials, more integrated into the market so that they become the standard?
Yes, I mean, the people in the construction industry are incredibly lazy and just want to use what they're used to. And I always say, if you want to find out the worst way to build, go and stand at the counter of a big builder's merchant and listen to the bad advice which is given out about what materials to use. So we do have a big problem there. The fantastic thing about Hemp Crete is if you could actually get a builder to come to a workshop and see how it's used, they're immediately converted. They say, my goodness, why do we not hear about this before? We should have been using this for years. It's really fantastic, so easy to use, and so on. But there is a serious laziness, and there is a lot of nonsense talked often about oh, you won't get approval from building control or whatever. But I think attitudes are changing, and I'm very encouraged by, there are young builders all over the UK now starting to use Hemp Crete, and a lot of them pester me for free advice as well, which I'm happy to give because, you know, I'm keen to encourage them. So I noticed there's a question on the chat about buying hemp seeds. Somebody's saying from Transylvania. Transylvania, where is that? That's not Romania, is it?
It is Romania, yes.
Yes, but Romania is one of the best places on the planet to source hemp. There's more hemp grown. In fact, one of the big Dutch companies, Hempflex, has moved much of its production to Romania. So actually, that's a really easy place to source hemp seeds. But if somebody needs advice in the UK, get in touch with the British Hemp Alliance. They will tell you where to go. Bit late to start planting hemp this summer because it's already be well out of the ground by now. But there's plenty of places. But Romania is one of the best places. Romania and Hungary are the two main sources of hemp seed in Europe.
That's interesting, thank you. And are there limits to the scaling of the technology, or are there only perceptions? In that, if there was increased demand, would it be possible to scale up to match the demand?
Yes, that's an important issue. I have quite a lot of conversations with mainstream construction. They're incredibly nervous about using anything that they're not familiar with or isn't standard construction. So, you know, they sniff around, but then don't go any further with it. And we need to make a big breakthrough with a big housing developer or housing association that's willing to build with Hemp Crete. The rediscovery project we did in Dublin, in Ballymun, was approved by Dublin City Council, and they were incredibly supportive. And maybe we need to get a progressive council like Manchester or somewhere that wants to go for zero carbon to support this. But in terms of scaling up, there is actually plenty of hemp at the moment. Obviously, if there was a huge increase in demand, we'd need to get more farmers to grow it, and we need more processing. But there are two big companies, one in England and one in Scotland, setting up new hemp factories in the near future. So the ability to meet the demand will be fine, at least for the next few years. Growing hemp is an ideal thing for agriculture. Farmers need to diversify, and it's very good to use as a crop between other arable crops. And hemp has lots of other uses as well, so it can be a food crop. So it really wouldn't be a problem. Using developing the binder as well, it'd be relatively easy to make those available and scale up the production. There's already a big factory in Shropshire, and the one that we work with in Northern Ireland would be able to scale up the production quite quickly if the demand was there.
Great. And what is the lifetime of a house built with hempcrete compared to traditional building materials?
Oh, I don't know. I'll be dead before we know that, because we built the hempcrete houses around for 30 years now, and no sign of any problems. So I don't see why they shouldn't last 100 years or more. We're in a sense replicating the kind of materials and technology that was used as long ago as the Middle Ages, and, you know, old timber frame buildings with lime have been around for a very long time. So I'm pretty confident that this has got a long, good life. Certainly hempcrete buildings will last an awful lot longer than the rubbish that they're currently putting up, that a lot of developers are using with lightweight insulation materials, which are overheating, are fire risks, and are problems with indoor air quality as well. They'll be coming down a lot sooner than the hempcrete buildings will.
Thank you. And you mentioned where you get your hemp from in terms of the projects you've been involved with. Does this have does the hemp have a carbon footprint associated with it?
No, I think growing hemp is a very important way to sequester carbon. So it's advocated as probably one of the best things that can be done, because you're absorbing CO2 much more quickly than you are by planting and growing trees, and it's an annual crop. So hemp has a huge contribution to make to reducing carbon emissions, and should be grown everywhere if at all possible.
Hempcrete use, can it be used in hot places like the Middle East? Is it suitable for that use there?
Yeah, it's the place I get most inquiries from is India at the moment. There's quite a lot of work going on in India. Some countries where hemp's still illegal, like Malaysia, they have a crop called kenaf, which is quite similar to hemp, which could be used in a similar way. Nepal is one of the big areas for hemp growing, because that's where a lot of the hemp fiber and clothes come from. It could be the big problem with in a very arid country would be water. You do need water for the hemp grow, but for instance in South Africa, I understand they're growing where they have big water problems. They're using hemp to clean up ground where waste water is goes onto the ground, and the hemp will clean that up very, very successfully. So it can be grown pretty well anywhere in the world, really. We've even grown up the side of a mountain in Northern Ireland where the weather wasn't very good at all. So it is actually remarkable. And there are many different varieties of hemp as well. So some are more suitable in different places. It depends which kind. I'm not an expert on the different kinds of seeds, unfortunately.
Great, thank you. Thank you for answering so many questions. We'll just do one more. I think that's all we've got time for. So there's an attendee asking about the need to grow hemp for this kind of use, also the need to grow crops for more biofuel, as well as food to feed everyone in the world. How do we balance the need, and is it possible to have enough land to grow all of those different things?
Yeah, well, I'm totally against growing crops to burn. I think it's a completely crazy thing to do. And you've got a situation now with power stations in England where they're importing wood pellets that are coming all the way from the United States, where they're clear felling forests to create the wood pellets which are brought over. And I know they're growing miscanthus and other things. I think growing crops to burn is ridiculous. We just need to insulate our buildings better so we don't need to produce as much energy and heat. And also, people need to get used to the idea of putting on another jumper when they're in the house if they're cold, instead of turning up the thermostat. So we need to be much more clued into energy efficiency and stop burning stuff, whether it's fossil fuels or biofuels. It's all equally bad. That's not a good thing to do at all.
Well, thank you so much, Tom, for such an interesting presentation and answering all of those questions. It was really great to have you on. That is it from us today, attendees. Thank you very much for logging in. I hope you found that beneficial and informative. And don't forget to record your attendance at the IES CPD tool. As I mentioned before, this webinar has been recorded and will be made available on the IES website and YouTube channel. If you're watching the recording on YouTube, please subscribe to the channel, like the video, and hit the bell to get notifications. Thank you again to our speaker, Tom, and for all of you for attending. See you at the next event. Thank you.
Thanks a lot. Bye.